Hey everybody, how we doing? Hope you're good. I'm going to go through a couple of these problems and do I get a marker on this thing? Here we go. Let's try this. What to go with today? That's a funky color. That's brown. Let's go with, what is this? Dark brown. What is this? Dark green. Yeah, let's go dark green. All right, so I'm gonna go through a couple problems. C and D. These graphs are pretty small, so normally I like to go visual and do the slope triangles, but what I might do is just go ahead and graph the points. So I got 0, 0, we got 5, 5, which is going to be right there. 6, 12, which is going to be way up there. And then 1, 7, which is going to be right about here. Can we scale this down a little bit? Yeah, there we go. All right, so here we go. A's down here, B was here, C was here, and D was here. Okay, so it definitely looks like a shape. And what I'm going to do again is, since the graph's real small, I'm going to just go with the formula out here, just get the lengths of each side and go with that. Okay, let me connect them a little bit better. Let's change the color up. Let's go with this. What is this? Red. Okay. All right, so I'm going to go straight by the formula. So AB, we're going to adjust those coordinates. AB is going to be that bottom side. So here we go. Using the distance formula. Distance formula goes something like this. X2 minus x1 squared plus y2 minus y1 squared. And it really is just a part of the Pythagorean theorem. Okay, which coordinates? So here we go. So on AB, I'm just going to start with that second x. So we got 5 minus 0 squared plus, and we got 12. It's going to be 5 minus 0. Get an eraser on here. Eraser. Didn't come out too well. So 5 minus 0. So basically you're going to have 5 squared, and I'm going to shorten this down as I go, plus 5 minus 0 is 5 squared. Oops, left that squared. Okay, which is going to give you 25 plus 25 is 50. And so we're going to go ahead and take square root of that. It should be like 7 point something. Let's go ahead and do that. Square root of 50 is 5 root 2, aka 7.1. Okay. Got it. I'm going to go and write it over here, 7.1. All right. Let's go ahead and do CD. So moving on to the next pair. So CD. So now we're going to do the top side. Going straight by the formula. All right, CD. So I got 1 minus 6 for the x's. Plus 7 minus 12 squared. So 1 minus 6 is going to be what? Negative 5? Negatives I like to put in parentheses just to keep control of the negative in there. Plus, don't want to lose it, 7 minus 12 is going to be another negative 5. So, but negative 5 times negative 5 is going to be a positive 25. And then that's going to be another 25, negative 5 times negative 5. So you're going to end up with the same square root of 50 in here, or the same 7.1. Okay, so top side 7.1. Here we go, BC. Let's do the right side. So BC. So let's do 6 minus 5 squared plus 12 minus 5. And as you start doing it, you start seeing, of course, the same numbers over and over. But let's just see what happens on this one. 6 minus 5 is 1. 1 squared is 1. This one will be a little different. 12 minus 5 is going to be 7. 7 squared is going to be 49. Uh-oh, look at this. We still get square root of 50, or 7.1. All right, dA. So going from D to A. So here we go. Since A is second, I'll use that as my second X. So we're going to have 0 minus 1 squared plus, and then 0 for the Y's minus 7 squared. So 0 minus 1 is negative 1, negative 1 squared. Better take my time on this one. Plus, and that's going to be a negative 7 squared. But if you square those out, you're still going to get 1 plus 49. Both are going to be positives because you square. Negative times a negative. So you're still going to get the square root of 50, and you're still going to get 7.1. All right, so right now you've got definitely a parallelogram. So right off the bat, it meets the parallelogram status because you got opposite sides are congruent. But if you got all four sides being congruent, that means now you are, and here's my train of thought here. I know it's a parallelogram right off the bat, but it could be a rhombus. Let me spell that, rhombus. And then it could be a square. So if you're going along the train of thought here, as soon as you know opposite sides are congruent, that's a parallelogram. As soon as you know all four sides are congruent, now it's a rhombus. Now the question is going to be this one. Could this be the square? Now it doesn't look like a square, so if you want to take a wild guess, you could probably say it's not going to be a square, it's just going to be a rhombus. But let's just do a little verification. They are going further down here with the length of diagonals, so let's change the color up and just see where that takes us. All right, so we're going to go AC. So AC is going to be from here to here. AC. So hang on, that's awful. Slightly better. All right, so AC, we're going to do the length of that one. And now where are they going with this? If they go with the length of diagonals, what we know about the diagonals of a rhombus is that they'll be perpendicular and they bisect. The diagonals of a square will be the same length. So if we end up getting the same lengths down here for the diagonals, that means it'll be a square. All right, so AC. So we're going to do 6 minus 0 squared plus 12 minus 0 squared. So that's going to give us 6 times 6 is 36 plus 144. This is going to give us a grand total of, I should be able to do that in my head, but it is way early, 180. And the square root of 180 is 6 root 5, aka 13.4. Okay, let's see what we get for BD. So now we're going to do BD. Let's change up the color again. Let's go orange. So now we're going from BD, cut across here. Okay, so we're going B to D, so I'll start here. So dx is 1 minus bx, which is 5. And we got 7 minus 5 squared. All right, let's do some crunching here. 1 minus 5 is going to be a negative 4. And then 7 minus 5 is 2. 2 squared. Okay, so 1 minus 5, negative 4 squared is going to be a positive 16. 2 squared is 4. So this is going to give you a square root of 20. And already you can see they're definitely not the same. What's the square root of 20? Finish this out. 4.5-ish. So these are definitely not the same. So that means that square is off the list and you are coming right back here to the rhombus. Because at least we know all 4 sides are the same. That is a rhombus. So how do you know that figure 8 is a rhombus and not a square? Well, we just went through that with our diagonals. Okay? So rhombus means that all 4 of your sides are congruent. To be a square, all 4 sides need to be congruent, and you need to have right angles. But the key thing here, since we went with the diagonals, is to be a square, the diagonals have to be, they got to do everything. They have to bisect, they have to be perpendicular, and they have to be congruent. So the square is like the ultimate parallelogram. All the properties of all the shapes, all the parallelogram shapes before it go into a square. All right, let's see here. How much time we got? I don't think we have time for a whole nother problem, so I may stop this one.